You must understand what you did. I gave you a recipe, but the recipe changes a bit for every scenario. Are you with me?
Yes, ma'am.
We will see. Okay, right. Then I'm on page 12. I think we completed it there. Yes. On page 12, I said, the effect of a non-volatile. Now, non-volatile is a thing that does not evaporate that well. Non-volatile does not evaporate. That is what non-volatile. The effect of a non-volatile solute is the thing, and most of the time it is a solid. Okay? A solid on the boiling point of a solvent. Okay. Now, I assume most of you have made food at home. If you're grade 11 and you haven't made food, then you must help out at home. Yes, you must. One of these days you're out of your house and then you must take takeaways. You guys will not have enough money for takeaways. And you'll get fat from takeaways. But anyway, we're not going into that. Yes, come on. Solid, like a cursive S. Polar. How do you get polar from that? I started with an S, a cursive S. Because solid, liquid, gas, you write solid, gas, liquid. You write cursive. Okay, anyway. Right, so let's say you are going to make noodles. Okay, not make 2 minute noodles, like in a pot noodles. Have you made it like that? Or rice? You've made rice? Okay, but I don't know if you make the pap the same way as me. You, no, when you first take your pot, then you add your water. What do you add next? Salt. Okay, good. Okay, we make it the same way. All right. So you add salt. Why do you add salt? Okay. All right. So you add salt for 2 reasons. Number one, for taste. But the second one is water on its own. You did this practical last year. At what temperature does water boil? 86, let's say 90 degrees Celsius. Okay? But you want your pap to be done faster. Okay? You want the water to boil not at 90 degrees Celsius, at 100 or 110 degrees Celsius. So what we do is we add salt to it. Because salt increases the intermolecular forces and it makes your pap, your water to boil at 100 degrees Celsius instead of 90 degrees Celsius. Okay, so that is one of the reasons why you add salt to it. That you call boiling. Just boiling of pap. Say again? Does it? Bake. I eat krummel pap. What do you call that? I don't come from the Free State, né? And in the Western Cape, we don't eat pap. You eat Weet-Bix or bread or yogurt. Or I didn't grow up with pap, but my husband, he loves it, and because he comes from the Free State, and he likes krummel pap with a sheba. I call it, in Western Cape we call it sheba. So I don't say it wrong. In Western Cape we call it sheba. Or in Afrikaans you call it smoor. Smoor.
Yes, ma'am, what is it in English? Soft or hard?
Say again?
The one that you put, is it soft or hard?
The pap. Krummel pap is hard. It's a little...
Do you eat it with meat?
Yes, with sheba, egg, sausage. Yeah. So my husband sometimes eats with milk, but I don't.
It's nice.
I'm not a free stater yet. Maybe we'll get there. Huh? I don't know what you're saying. Well, Amazi. I bake with Amazi, but I don't drink it. My mother loves it. She drinks it like this. Yeah. All right. Thank you. It's just I didn't grow up like it. My husband did grow up, and he loves it. Me, not so much. Yes, she's from the Free State. And my mother is from the Eastern Cape, so she also loves the pap and the amazi and blah, blah, blah.
It's nice.
Say again? Lactose intolerant? No. I just tried. Alright. Okay, so the moral of the story here is why do you add salt to your water before you boil anything? To increase the boiling point. Okay, and this is what we're going to investigate here. It says evaporation is a surface phenomenon. It means it happens on the surface. Something doesn't evaporate from the bottom, it evaporates from the top. Then, the presence of a solute, something that you dissolve like sugar or an ionic substance like salt, dilutes the number of solvent particles on the surface, and the solute's attraction on the solvent makes it more difficult for the solvent to evaporate. Okay, and I'm going to explain that with a picture because I don't think you understood anything I just said. Then, thus the vapor pressure of a solvent decreases, the vapor pressure decreases, and the boiling point increases. Okay, so I'm going to explain it with a picture here at the bottom. Okay. So at the bottom here, kom, vinnig. Okay. On the left-hand side is just water. So that represents water. Okay. And if we heat that up, then the water particles starts to move faster, and they will start to evaporate here. Right. Okay. So what type of intermolecular forces do we find between water molecules? Okay, right. Then on the right hand side is a picture of, let's say, you have water and salt. Salt is sodium chloride, I thought.